let's make use of a grid to try to list down all the possible outcome for x. So according to what the question says, we are going to be throwing the dice 2 times. So let me draw this grid that represents the first throw and the second throw. For each throw, it is going to be 1, 2, 3, 4, 5, or 6. This, let's say, is the first throw, or it will be 1, 2, 3, 4, 5, or 6 for the second throw. And according to the question, x is going to be the smaller of the two scores if they were to be different, and it is going to be the common value if they were to be the same. So for example, this is common value, so it's going to be the same 1. These are two scores. We will take the smaller of the two, so it's going to be 1. The same for this, it is going to be 1, 1, 1, 1. So 1 and 2, we will be taking the smaller of the two scores. It is going to be 1. 2 and 2, it is going to be the same value, so it's going to be 2. And this it is going to be equal to, I will take the smaller of the two values, it is going to be 2. This is also going to be 2, 2, 2. 1 and 3, the smaller of the two values is going to be 1. 2 and 3, the smaller of the two values is 2. 3 and 3, it is going to be the same as the value. It's going to be equal to 3. The same for this, smaller of the two values is going to be 3, 3, 3. So we will have this, and this is 1, 2, 3, 4, 4, 4. And this is going to be 1, 2, 3, 4, 5, 5. And this is going to be 1, 2, 3, 4, 5, 6. And we're supposed to show that probability that x is equal to 2 is equal to 1/4. And now if we were to count the number of cases that 2 appears, 1, 2, 3, 4, 5, 6, 7, 8, 9. It appears 9 times out of 36 times. So 9 over 36, this is equal to 1/4, and this is what the question wants us to show. We are supposed to list down the probability distribution for x. So we are going to try to make use of a table to list down this probability distribution. So in my table, I'm going to have x versus its corresponding probability when x is equal to x. So all the possible outcomes for x will be 1, 2, 3, 4, 5, 6. So let me write down the possible outcomes first. So 1, 2, 3, 4, 5, 6. I can see them here. These are all the possible outcomes. So getting a 1, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 out of 36. Getting a 2, we have 1/4, or I'm going to just write it as 9 over 36 so I can have the same denominator throughout my distribution table. 3, I have 1, 2, 3, 4, 5, 6, 7. So we have a 7 out of 36. For the number 4, it appears 5 times, so 5 out of 36. The number 5 appears 3 times, 3 out of 36. And 6 appears 1 time, 1 out of 36. To find the expectation of x, it is going to be making use of the formula where we try to sum all the x multiplied by its corresponding probabilities. So the expectation of x is going to be 1 multiplied by 11 over 36 plus 2 multiplied by 9 over 36 plus 3 multiplied by 7 over 36, and then 4 multiplied by 5 over 36, and 5 multiplied by 3 over 36, and finally 6 multiplied by 1 over 36. So if we were to calculate this, we will get the expectation, and that is going to be 91 over 36. And to find the variance of x, we are going to first find the expectation of x squared. So the expectation of x squared is going to be sum of all the x squared multiplied by the corresponding probabilities for x. And this is going to be equal to 1 squared multiplied by 11 over 36 plus 2 squared multiplied by 9 over 36 plus 3 squared multiplied by 7 over 36 plus 4 squared multiplied by 5 over 36 plus 5 squared multiplied by 3 over 36, and finally 6 squared multiplied by 1 over 36. And this is going to be equal to 301 over 36. And now we will find the variance for x, because it is going to be expectation of x squared minus away the expectation of x square. So it is going to be equal to 301 over 36 minus away 91 over 36 square. And the variance is equal to 2555 over 1296. Let's calculate for the probability that Ivan wins the game. So for Ivan to win the game, Ivan has to be scoring an x is equal to 2. And since Ivan will be playing first, it is possible that the very first time when Ivan plays, he is going to be winning the game. And that is going to be simply 1/4. Or it can be when Ivan plays the game, he's not going to be winning the very first time when he plays, so 3/4. John plays the game and John is also not winning, 3/4. And then Ivan wins, so it's going to be 1/4. Or it can be Ivan not winning during the first game and John not winning during the next game, and then it will be back to Ivan, and Ivan is still not winning and John is also not winning. Then Ivan gets to play again and Ivan wins, and I can continue and continue and continue. And if I were to just consolidate the probabilities that I have, it is going to be 1/4 plus 3/4 square multiplied by 1/4 plus this will be 3/4 to the power of 4 multiplied by 1/4 and all the way till infinity. So what we are seeing here is a GP. A GP with the first term as 1/4 and the common ratio is 3/4 square, because from this to this it is multiplied by 3/4 square. From here to here it is also going to be multiplied by 3/4 square. So 3/4 square is going to be the common ratio of the GP. We are using the sum to infinity of a GP formula, A over 1 minus R, and this gives us a 4/7. This makes it possible for us to come up with the distribution, the probability distribution of Ivan's gain. I'm going to let Y be Ivan's gain. So its probability distribution table will look something that is like this. Y, and all the possible outcome will be Ivan gaining $7 from John or Ivan losing $10 to John. And the corresponding probability for Ivan's gain we have just calculated. For Ivan to be winning, it is going to be when Ivan gets $7 from John. The probability is 4/7. And for Ivan to be losing money to John, it is going to be the complement of this. So 1 minus 4/7, this is 3/7. And now we can actually calculate for the expectation of Ivan's gain, since we have the probability distribution table, and the expectation will just be sum of all the y's multiplied by the corresponding probabilities. And this is equal to 7 multiplied by 4/7 plus minus 10 multiplied by 3/7. And for this, we are getting a negative 0.29, which means that we are expecting Ivan to be losing 29 cents. And if Ivan's expected gain is negative 29 cents, that means John's expected gain will be positive 29 cents. And that is why comparing both players, which one will have a higher gain? John will be the one that will have a higher gain.